Hello guys, today I will be explaining you about a blockchain based voting system project, and we have named it as OVM or Onchain Voting Machine. So let's start it. At first, as you can see, this is the project's GitHub repo. From here you can just simply copy it or clone it in your local. So let's first understand how it's work. So it's not like other blockchain based voting system that you would probably found on the GitHub or the internet. It has some unique features, like it uses Soulbound token or SBT to authenticate the users, and it ensures that one voter who has the SBT can only vote, and without this SBT no one can vote. Also, this SVT ensures that without this, anyone could not participate on the voting process. Also, as we all know that doing some transaction in the blockchain space required you to pay some gas fee or the transaction fees, and which is very inconvenient, as many of some people who don't understand this crypto and blockchain like these technologies, and they may not have the fund on their wallets. So for this we have used something called gasless meta transaction, which would not let them pay the transaction fees. So this voting process will be free of cost for everyone. Okay, so let's start to clone this project on the local. So as you can see in my VS Code, I have cloned it already. So as you can see, this project has three separate sections like backend, frontend, and smart contract. And by the way, you can see that here is a .env.example file, which is basically an example of a env file. I will go through each of this one by one. So at first, let me open this env file. I have filled it with some demo values. So let's start filling one by one. At first, here is a private key. So it's basically a wallet address of the admin or the person who will be deploying this smart contracts, and we will play the role of an admin. So let's first open our MetaMask wallet. For this you would require a MetaMask wallet, which is a Web3 wallet. As you can see, you can download it from here, and not this. You can search it on Google, and from there you can download it. So let me open the MetaMask. And from here just simply click on this account, then in three dot and account details, and click on show private key. Okay, then enter the password you have entered during the wallet setup and hold it. Okay, this one is your private key. Just simply paste it on here. Then this admin address. This is simply the wallet address of this one, which is this. Just copy it from here and paste it here. Now you would require a Alchemy RPC. So it's the URL of the RPC which will let us interact with the blockchain node. Sorry. So let's first open Alchemy's dashboard. Just sign in here. I have done this already. And from here, create a new app. Create a new app. Named it anything. I am giving it name as OVM demo. Then use case, you can give it anything. I am giving it as NFT, and next. On the chain we have used base chain. which is a layer 2 solution by Coinbase, and create app. From this, here is the API key, and this one is required by us. Just change the network to Cephalia and copy it and paste it here. So these three sections are done. Now the Pinata part. So the Pinata is a gateway which will let us interact with the IPFS, which is a decentralized file storage. For that, open Pinata Cloud and login. Okay, I am changing it here. Here I have logged in. Okay, this one is done. Now go to the API key and from here create a new key and select the admin and name it anything. I'm giving it name as OVM demo. Okay, OVM demo, and generate the API key. First click on this API key, paste it here, then select this API secret, paste it here, and then this JWT, I'm deleting it, copy it and paste it here. So the environment variable is now set. Now let me open the front end part and click on this env and also fill this one. So for this again we will require the admin address, which is basically this wallet, this wallet's address. Just simply copy it from here and paste it here. And for the Byte API base URL, actually this is the URL of the backend server. For the local development it is usually this one, 127.0.0.1:5000. Okay, now all the environment variables are now set. So now let us deploy a smart contract for this project. Simply open this contract folder and from here you will find these two, voter ID and voting system. So this voter ID is the SBT which I have talked earlier. So this one will ensure the authenticity of the user. Later I will explain you more while I demonstrate the project. Okay. So for deployment of this project, I will use Remix ID. You could use anything like Foundry or Hard Hat. As of now, I'm using Remix and it is more convenient for me. First create a file. I'm naming it as sbt.sol and pasting the code here. Just simply click on OK. Now go to here, Solidity compiler, compile it, and if it is successful then here a green tick will come. And now click on this and select the environment as injected provider MetaMask. Okay, your MetaMask will be connected. Check from here and your wallet address will be shown here. Now from here just click on deploy and your wallet will be popped up. Oh, by the way, before doing this, make sure to add base Cephalia chain on your MetaMask. For this you can use chain list, include testnet and search for base. You can see it here, base Sefolia testnet, and this chain ID is this. Please ensure this one. And all the RPC URLs will be shown here, and all of this may not work. For mine this worked properly, and from here click on the add to MetaMask. Then your MetaMask will ask you for confirmation and it will be done. Okay, now coming back to the deployment, you can see it as MetaMask wallet address, and before doing this, please make sure that this base Sefolia testnet is selected. And to deploy this, you would require some testnet fund on base Sefolia chain. For this, you can use some faucets like Alchemy or any other but from there you may require some funds on their mainnet. So if you don't have any fund or you cannot get any faucet, then please ping me on GitHub. I will provide you the faucet. Okay, now to deploy this, simply click on deploy. Now confirm it. Let us wait for some time. Oh yeah, it's done. From here, copy this address. This is the contract address, and open the artifact, voter ID and ca.txt. Copy all and paste it. Again go back here and click on this, and from here click this ABI. Copy the ABI. Okay, come back to the ABI.json under the voter ID. Select all, paste it here. Do the same for the bytecode. Select all and paste it here. Now the voter ID has been deployed successfully. Now coming back to the voting system. So it's all the logic of the voting system, including the candidate add, the voting state, voting calculation, etc. Okay. And now coming back to the remix, create a new file. I'm giving it name as vote.sol and paste the code here. Allow it. Okay, now coming back to here, Solidity compiler, it's compiled successfully. Deploy and run. From here, make sure to change this to this one, voting system. Okay, please do not deploy this one. Only select this voting system dashboard.sol. From here from here you can see you require two parameters. This requires two parameters. Okay, one is VID address and another one is the relayer. So VID address is nothing but the contract address of this voter ID. So copy it from here and paste it here. So for the relayer, this is actually that address which will pay on behalf of the user during the voting system, which I have talked earlier as the meta transaction, which will let the user vote without paying any gas fee. Okay, so for this project, our admin's address will be doing this. So I'm copying the admin's address and pasting it here. And click on transact. It will deploy this contract. Okay, let it keep some time. And it's done. Copy this address and do the same. Open this voting system under the artifact. Click on ca.txt, Ctrl A and V. From here, select this one. Please ensure this voting system and copy the ABI. Paste it here. Do the same for bytecode. Okay. Do the same for the bytecode and paste it here. Okay, it's all done. Now the contract has been deployed successfully. Let me close this. Close all. Okay. Now coming back to the backend. Okay, so this backend consists of these many files. These all are very much important to run this project. Okay, so first install all the requirements. Okay, pip install -r backend requirements.txt. All these processes are documented in the GitHub too. You can check it from here. As fast the dependencies are installed. Okay, it's installed. Now initiate the database. Okay guys, I have finally solved the problem. It's actually because of the Python 3. So it's the command for the Linux environment, and as of now I am in the Windows environment, so we won't be required these 3. Okay, so for Windows simply remove these 3 and run this. Okay, a db folder has been created. It's something I will be showing you later. Okay, now let us start the original app. So this will open some routes on the backend, which will serve as an API for our front end. Again, go back to the GitHub and copy it and paste here and remove this 3. Okay, give it some time. In the meanwhile we are okay, let us initialize the front end. Okay, cd, and I'm seeding to the front end. Okay, as you can see, we are inside the front end, and from here at first install npm I, which will install all the required npm packages. Give it some time. Let's see. Okay, it's done, and also our backend is ready. Now let's start the npm server, npm start. Okay, it's done. Yes, so this is our interface of the OVM. Let's first connect a wallet address. Okay, it will ask you to switch the chain to the base Cephalonia testnet. Approve it. Okay guys, while recording, this RPC URL is not working, so for this the chain is not being changed. Okay, let's see. We have enabled base Cephalonia testnet from here. Let's connect it, and the wallet has been connected successfully. So we have selected this wallet as the admin wallet, right? Admin address. So for this will trigger the admin actions. Let's check on the backend. Is it connecting? Okay. Okay guys, I have made a small mistake while explaining about the setup of the CNV file inside the front end. I omitted this part http:// but this is necessary and this is mandatory to put before this. Okay, for this reason the front end was not working properly that time. Okay, now it's been fixed, and let's refresh this page once and connect it. Okay, I have connected with another wallet address. You can see it from here, and it is not our admin's address. Okay, so this will be our user's wallet address. From here you can see the user details. From here you can see it's not a verified user, and voter ID and boots are not available. So this voter ID is basically a unique ID number which will be embedded into the SBT, and this both will also be a parameter of that SBT, and this is the area of the voter. Let's open the enter dev. It will ask the user to complete the KYC. It's not done yet, so let us complete the KYC now. Okay, you can see here is the full all details for the user, and please make sure that all of these details need to be correct as of the document. It will recheck the details with the document and the face which will be taken from here. Okay, so let me fill all these things. By the way, I apologize for this annoying keyboard sound. This is the mechanical keyboard which will make lots of noise. It's a fake number, by the way. Let me see my Aadhaar card and fill it here. I am opening it side by side. Now you would be required to upload your Aadhaar card's image. By the way, we support only Aadhaar card as of now. I am uploading my Aadhaar card, and now I will be required to capture my face. Allow it. Capture it from here and submit it. Now these data will be sent to the backend. And by the way, all these data will not be sent to the blockchain. Okay, I may have done something wrong. Okay guys, you can see this board has been done successfully, and you can see a transaction hash here. Let me see. Okay, from here you can see it is a voter ID and it's been sent to the voter's address. And this section is supposed to show the listed candidates for this user's area, but this is blank now. I will show you later. And you can see this user is now verified and he has a unique ID number, and this is his booth. Okay, so now switch back to the admin's role, change the wallet, disconnect it from here. Let's connect the admin's wallet address. Ignore this for now. From here you can see the user's control and all the details of the user who have completed the the KYC process. From here you can see different sections like candidate controls, start vote and end vote. Let me clear you that before starting the vote, admin can add the candidates. Okay, after the vote started, the admin cannot add any new candidate. So let us first check the vote status. The vote has not yet started. Okay, now you can add it from here to and from here to. Let me add a candidate. I'm giving it name as candidate 1. select the booth. Let me select this one, party as party 1, and upload photo. I'm selecting this photo. I don't know who are they. So what this thing is doing is that first this image, what's wrong? Okay guys, as you can see, a confirmation for the adding candidate has been popped up to the MetaMask wallet of the admin, and from here simply confirm it, and you can see it, candidate 1 added to the candidates. Okay, so candidate 1 is now a candidate for Baj area. Okay, let us add another candidate. By the way, only one candidate can participate in the voting process from one party in a area. Okay, let us try to add another candidate in the same booth in the same party. Okay, let's see if it's successful or not. Let us open this console. Yeah, you can see it's reverted. Okay, so select the party 2, submit it. By the way, I forgot to explain what is happening under the hood. So at first this photo of the candidate is being uploaded to the IPFS, which is the decentralized file storage, and for this we require the pinata, which I have told you earlier, and on that IPFS we are storing this candidate's image, and all these details like name, booth and party are being stored in the contract, this one. Okay, this voting system contract. Yeah, this one also successful, and from here candidate controls, you can see these two candidates are added successfully. Okay, now switching back our role to the voter, let's disconnect this wallet and change it to voter and connect it. Okay, now I am a voter and enter tab, and you can see from here these two candidates, and the voting has not yet started. Okay, so for the simplicity, let me open another tab, and on that tab I will be the admin. Okay, 127.0.0.1. okay. So this is the user's wallet. Switch back to the admin. Okay, now you are admin. From here you can see the candidates, and let me start this voting process. Okay, you can see this start vote. Start vote request has been successfully sent to the MetaMask, and simply confirm it. Okay, and the vote has started successfully, and the transaction is also confirmed. Now log back to the user. Let's try to vote for candidate 2. Okay, now this time you can see that this user is not being asked to pay any transaction fees, and I am opening his MetaMask wallet. Let's cancel this time, and you can see this one is the user's wallet, and you can see this user has nothing. Okay, now let's try again and confirm it. Okay, Okay, you can see this time and the user has successfully voted, and this is his transaction details. From here you can see all these details, and let's try to vote again and see if this user can vote again or not. No, this user cannot vote again. Okay, so the vote is successfully started, and other users can also do the KYC and opt for the voting process. Okay, now let's end this voting process. Confirm it. Vote has stopped successfully. Okay, check the stat. Vote has not started yet, means it stopped. And by the way, the result has not declared yet. Okay, declare the result. Without declaring the result, no one can see the result. Okay, confirm it. The result has been declared, and from here you can see the check result section. Okay, okay, this is the dashboard for the user, and from here user can see the status. Okay, you can see the winner is the candidate 2, he got 1 vote, and this blah blah. And now on the admin section you can see the admin can see this pie chart showing the details. You can, if other candidates also got some votes, then it can be shown here, and here is a tabular format. Okay, so that's all for the OVM. These are all the features, and I tried my best to explain all these things. I didn't explain the code because for these things you have to learn the core parts of the blockchain, like how the blockchains work, what is the SBT, concept of SBT, what is meta transaction, and this kind of things you have to learn first. Okay, and my English is broken, by the way. I apologize for that. I tried my best to speak as good as I can. So this all from my side. Thank you for watching.